right, let's go to slide 6, finding our mean. First thing we're gonna do is add them up. I'm gonna chunk it, so I'm gonna add these 4 and then those 4, and then add those numbers together just so I don't have to type so much and mess something up. So 100 plus 54 plus 98 plus 96, this is 348. And then clear that. On the other side, I got 89 plus 90 plus 89 plus 96, which is 364. And then I'm just going to add those two together. So 364 plus 348, which is 712. Now I can divide by how many numbers there were. There were 8. So 712 divided by 8, which gives me 89 for my mean. Now for my median, I'm going to take those original numbers and I'm going to relist them least to greatest. So 54, cross it off. Then I see 89 and another 89. Oopsies. And then 90, 96, another 96, 98, and 100. Okay, and I always just double check that I have the right number of numbers. So 1, 2, 3, 4, 5, 6, 7, 8. Yep. Then we cross them off, working our way in. So cross it off, cross those off, cross these two off. Again, I've got 2 in the middle. In between 90 and 96, maybe you know that. If you don't, you add them. 90 plus 96, which is 186. Divide by 2, which gives me 90. See, it's the wrong spot. 93. Okay, my mode, remember mode is the one that's repeated the most often. So I can see here I had 2 96s. I also had 2 89s. So they are both my mode. 89 and 96 were both repeated the most. My range is my biggest, 100, minus my smallest, 54. So 100 minus 54 gives me 46. Outlier, so the one that doesn't match the rest, it doesn't quite fit in. This 54 is going to be my outlier. Everything else is around like 90. Again, if these are test scores, these are all basically A's, and then this one F. So 54 is my outlier. My inner quartile range, this one's a little bit tricky. So if we find our median there, if you were making a box plot to find our quartiles, we would do the median on both sides of that median. So I'm going to cross off here and here. In between these two are 89. Cross off here, here. And between these two are 97. And then my inner quartile range is taking the range of those two. So 97 minus 89. 97 minus 89, which gives me 8. So my inner quartile range is 8. Okay, just a couple more. Statistical questions. Remember, these are questions where you would get multiple pieces of data for your answer. So what was the temperature in Fairbanks, Alaska on December 10th? No, that's going to give you one answer. What was the daily high temperature in Fairbanks, Alaska for the month of December? Daily high over the course of a month. So like 30 days, 31 pieces of data. So yes, that is statistical. How many books were checked out from the library this week? Okay. This week makes it sound like multiple days, but it's just asking for a total for the whole week, so no. What were the test scores for each student in your social studies class? That each student thing makes this statistical, because someone's going to get one score, someone else is going to get a different score. When does every person in your family go to bed? This is going to give you multiple pieces of data. You go to bed at 9, someone else goes to bed at 10. Okay, every person's telling you multiple people. What is your favorite color? Nope, that's asking one person for one piece of data. And how many people in your math class like otters? You're going to get one piece of data from that. 13 people like otters, something like that. All right, looking at this dot plot, what is the overall pattern of this graph? Remember, draw your little outline to help you out. This is definitely a skew. Remember, it's a name for the tail when it's a skew. So this is a right skew. Are there any gaps in this data? So right here is a spot that doesn't have any data on it. So yes, there's a gap at 5. Not at 7. 7's just the end of the graph. Are there any peaks in this? I would say there are no peaks. Remember, it's got to be that mountain. It's the top of the mountain. None of these are quite mountains going up, so no. Is there a line of symmetry? Okay, a skew will never have a line of symmetry. Remember, the two sides, if you drew the line, the two sides left and right would have to match or be really close. So here there is not one. Is there a cluster? Yes, remember a cluster has to be next to a gap, a big clump of data that's broken off from other data. There it is. So yes, it's from 1 through 4, all the way up to the gap. So the gap's at 5, it's 1 through 4. What % of the data is 2 or less hours spent on homework? 2 or less. Okay, so here's 2 or less. So I'm talking about these. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 dots out of 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 out of 20. Change it to a % means out of 100. Cross multiply 11 times 100, which gives me 1,100 divided by 20, which gives me 55%. Okay, finally, independent and dependent variables. So our independent variable for this first graph, remember independent is always along the x-axis, so our independent is the number of minutes on hold. Okay, and our dependent is here on the y, so that's the number of customers willing to wait. Okay, oopsies. All right, over here in our situation, Natalie can bake 20 cakes in a week. How many C cakes can she bake in W weeks? Okay, so our independent is our weeks, right? Time is usually an independent. Our dependent is going to be how many cakes she can make. The cakes depend on how many weeks she's baking them for. So cakes. And our equation is going to look like the cakes she can make are equal to 20 times however many weeks she bakes for. So she does 20 per 1 week. So 20 times however many weeks will tell us how many cakes she can make. And that's it.